Let A, B, C be the three given points in the xy plane whose position vectors are. The 3 points are given respectively with respect to the origin. The distance of the point C from the line bisecting the angle between the vectors OA and OB is 9 by root 2. Then the sum of the possible values of A is. So let us write first what is given. I have taken the points A and B in the xy plane here with respect to the origin. Now, let us find the slope of the line OA. So, slope of the line, now we find the slope of OA. O being the origin and A is the point root 3, 1. So, slope, we use the formula y2 minus y1 by x2 minus x1. So 1 minus 0 divided by root 3 minus 0, we get 1 by root 3, which is equal to the slope m. Tan theta is equal to 1 by root 3, which implies theta will be is equal to tan inverse of 1 by root 3, which is equal to 30 degree. Similarly, we find the slope of OB, where O is the origin and the coordinates of B are B is equal to 1, root 3. Which gives us slope will be is equal to root 3, 1 minus 0. Root 3 minus 0 divided by 1 minus 0 gives us is equal to root 3 will be the slope. M is equal to theta, tan theta, where theta will be is equal to tan inverse of root 3, which gives me theta is equal to 60 degree. Now from the question, the angle bisector, the line bisecting the angle between the vectors OA and OB. So let this be the line bisecting OA and OB. If A will be is equal to, A makes an angle 30 degree, B makes an angle 60 degree. Therefore, this bisector will make an angle will be is equal to, what is the angle bisector here? Angle bisector will be is equal to 45 degree. So this will be is equal to 45 degree. Tan theta is equal to 45 degree. The line bisecting OA and OB will make an angle 45 degree. Therefore, we can say that the equation of the bisecting line will be the line passes through the origin. The equation of the bisecting line will be is y is equal to x, or the line can be written as x minus y is equal to 0. From the question, the distance of the point C from the bisecting line between the vectors OA and OB is 9 by root 2. So we can find the distance of C from the bisecting line using the formula here. Given C vector is equal to, from the question, AI cap plus 1 minus A into J cap. Distance of a point from a given line, we know D is equal to modulus of AX plus BY plus C divided by root of A square plus B square. Distance of a line from a given point, we know the formula to find the distance of a line from a given point. So using this, the distance of the point C from the line x minus y is equal to 0 gives us, this is equal to modulus of 1 into the points of A are given. So 1 into A plus minus 1 into 1 minus A divided by root of 1 square plus 1 square, which gives us from the question this distance will be is equal to 9 by root 2. Now simplifying this equation, this gives us is equal to 9 divided by root 2, or this implies plus the modulus is there, so we give here, if A is equal to plus 9, 2A minus 1 will be is equal to 9, where A is equal to, we get 5. If A is equal to, if 2A minus 1 is equal to minus 9, 2A is equal to, we get minus 8, and A is equal to minus 4. So which implies the values of A are 5, minus 4. Here the question is find the sum of the given values. Therefore, the sum of given values will be is equal to 5 minus 4, which is equal to 1. This question is very simple. If the components of A vector is along and perpendicular to B vector, respectively are given as two vectors, then alpha square plus beta square plus gamma square is equal to. So given here, so in this question, A is given as alpha, beta and gamma, and A is along and perpendicular to the B vector. Along and perpendicular to the B vector. Therefore, A vector can be written as A vector will be is equal to 16 by 11 times of 3 I cap plus j cap minus k cap plus 1 by 11 times of minus 4 I cap minus 5 j cap and minus 17 k cap. 44 divided by 11 I cap. Next, it's 16 into 1 minus 5. So that is plus 11 by 11 j cap is 33 k cap divided by 11. Now, this is equal to, further simplifying, this is equal to 4 I cap plus j cap minus 3 k cap. Now, comparing these values with the given A vector. So, comparing with the given A vector, which is equal to alpha I cap plus beta j cap plus gamma k cap, we get the values of alpha, beta, gamma. Alpha is equal to 4, beta is equal to 1, and gamma is equal to minus 3. And therefore, we are asked to find the values of alpha square plus beta square plus gamma square, which is equal to 4 square plus 1 square plus minus 3 whole squared. So gives us this is equal to 16 plus 1, 17 plus 9, which is equal to 26 will be our answer. Next question, A vector, B vector and C vector are the three vectors such that C is coplanar with A and B and the vector C is perpendicular to B given A dot C is equal to 5 and then we have to find the value of mod of C vector. C vector is unknown to us. So let us take C vector will be is equal to some C1 I cap plus C2 j cap plus C3 k cap. Given the three vectors are coplanar. So the determinant of components of the A vector given in the question, components of A vector in the first row, components of B vector and the components of C vector will be is equal to 0 since given they are coplanar and C1, C2, C3 is equal to 0 since the vectors are coplanar, which implies that we get 1 into C3 plus C2. C3 plus C2 minus 2 into 3C3 plus C1 plus 3 times of 3C2 minus C1 is equal to 0. So simplifying this equation, we get minus 5 times of C3 plus 10 times of C2 minus 2 minus 3 minus 5 times of C1 is equal to 0. So otherwise I can write it as minus 5C1 plus 10C2 minus 5C3 is equal to 0. Let us have it as equal. C is perpendicular to B and therefore C vector dot B vector is equal to 0. So taking the dot product of B vector and C vector, we get B vector given from the question. So taking the dot product, we get 3 times of C1 plus C2 minus C3 is equal to 0. Taking this as the second equation, then given in the question that A dot C is equal to 5. A vector dot C vector will be is equal to 5. So taking the dot product, we get C1 plus 2C2 plus 3C3 is equal to 5. And we take this as equation number 3. Solving the three equations, we get the value for C1, C2 and C3. Get C1 will be is equal to 1 by 6, C2 is equal to 2 by 3 and C3 is equal to 7 by 6. Our question is to find mod of C. Therefore, mod of C will be is equal to 1 by 36 plus 4 by 9 plus 49 divided by 36, which gives us this is equal to root of 1 plus 49 gives us 50 divided by 36 plus 16. So 50 plus 16 divided by 36, which is equal to root of 66 divided by 36, or our answer will be mod of C will be is equal to root of 11 divided by 6. Again, we have a simple question here given A vector and B vector. C vector is such that A cross C is equal to C cross B and the dot product of A plus B and B plus C is equal to 168. Then we find the maximum value of mod of C square. Given A vector, B vector, and it is also given that A cross C is equal to C cross B, and we can simplify this by taking A cross C will be is equal to minus of B cross C using the property of the cross product. So this can again be written as A cross C plus B cross C is equal to 0, or further simplifying using the distributive property A vector cross B vector cross C vector is equal to 0. Now, the cross product of two vectors are 0. So when is the cross product 0? When the two vectors are parallel or collinear, and therefore we can write it as A vector. This is A vector plus B vector. A vector plus B vector. So cross product of both the vectors are 0, and therefore we can write A vector is equal to some scalar times of A vector plus C vector is equal to scalar times of A vector plus B vector, and therefore which gives us C vector will be is equal to lambda times of A vector and B vector C vector. Therefore, let us find what is mod of C square. Mod of C square will be is equal to lambda square into 5 square 25, 6 square is 36 and 4 square is 16, which gives us mod of C square will be is equal to lambda square into 77, or it can be written as 77 lambda square. Now, next, given from the question, the dot product of A plus C and B plus C is equal to 168, and therefore we can open the bracket and write it as A vector dot B vector plus A vector dot C vector plus C vector dot B vector. C vector dot C vector is mod of C square will be is equal to 168 B plus this can be written as A dot C and C dot A is dot product is commutative, we know, and therefore we can write this as C vector dot A vector plus B vector. Mod of C square is given to us to be 77 lambda square, which is equal to 168. Just a simplification. Plus 3 gives us 14. Therefore, C vector dot A plus B gives us C vector is known to us. A plus B vector, we know, adding A and B, we get the same 5i cap minus 6j cap plus 4k cap. Now, taking the dot product of these two vectors, this gives us C dot A plus B, gives us lambda into 5i cap minus 6j cap plus 4k cap, the whole squared, plus 77 lambda square will be is equal to 168 minus 14, which is equal to 154. Now, expanding the equation, 5 square 25, 6 square 36 plus 4 square 16. So adding these we get 77 lambda plus 77 lambda squared minus 154 is equal to 0. So dividing by 77, we get lambda square plus lambda minus 2 is equal to 0, which gives us lambda is equal to minus 2 comma 1. Now, when lambda is equal to minus 2, of C squared will be is equal to 10 squared plus 12 squared plus 8 squared, which is equal to 308. More C vector is equal to 1 times of 5i cap minus 6j cap plus 4k cap, which implies mod of C square will be is equal to 5 squared plus 6 squared plus 4 squared. We know that is equal to 77, and naturally the maximum value occurs when C is equal to when lambda is equal to minus 2. So from the question we want the value of maximum value of mod of C square. Therefore, we know that modulus of C square is equal to here 77 lambda square. So maximum value occurs when lambda is equal to minus 2, and therefore mod of C square will be is equal to 77 lambda square. Now this is equal to 77 into minus 2 the whole square, which is equal to 4 and this is equal to 308 will be our answer. Another simple problem, A vector given, B vector is equal to A cross I minus 2k and C vector given, B cross k cap. Projection of C minus 2j on A vector is. Projection of C minus 2j on A is C minus 2j dot A vector divided by mod of A vector. So given A vector is equal to A vector cross I cap minus 2 k cap from the question. So the cross product of the vectors gives us this is equal to I cap, j cap, k cap and the 3 minus 1, 2, 1, 0 minus 2. Expanding the determinant we get I into 2 minus j into minus 8 plus k cap into 1. This is equal to 2 I cap plus 8 j cap plus k cap will be our B vector. Vector is equal to B vector cross k vector. So taking the cross product, B vector is 2i plus 8j plus k cross product with k cap. I, j, k taking in the cyclic order, we know that J will be positive, J cross K will be positive, and K cross I will be positive. So taking the cross product, I cross K will be is equal to minus 2J. I cross K. I cross K. So the direction is reversed here and therefore we give a minus sign. So we get minus 2J. J cross K will be is equal to plus 8 into I cap. K cross K will be is equal to 0. Cross product of the same vectors is 0. So this is nothing but is equal to 8 I cap minus 2 j cap will be our C vector. Now moving on to the question, projection of C minus 2j on A cap will be is equal to 4 plus 4 divided by root of 14 which is equal to 28 divided by root of 14. This is equal to divided by root of 14 and our answer will be 2 times of root of 14. Projection of C minus 2j on A vector.